All right, hi everyone. Welcome to the Pixijs webinar. Here we have Matt Groves, the creator of Pixi.js, joining us all the way from UK. Today, he's going to cover what Pixi.js is and how it can be used in projects. At the end of the presentation, there will be Q&A sessions. So if you have any questions along the way for Matt when he's doing his presentation, or if you have any question right now, please post them on the comment section below, and we will address them at the end of the presentation. So without further ado, I'll let Matt take the stage.
Okay, hello everybody, hope you're all doing well. Right, let's get straight into it. Okay, cool. So this talk is basically about Pixi.js and an introduction to it. A quick little bit about myself. My name is Matt Groves. Like most of you guys, I am a JavaScripter, love to make things in JavaScript. I especially love to make games and experiences. And I currently work at a company called Good Boy Digital, which I co-founded about 3 years ago. And we basically specialize in making HTML5 content. And a quick overview of today's talk. So first thing is just a general overview of what Pixi is and what Pixi isn't. And then sort of jump into some code, and I can just show you guys how to create today's talk. Hello. Oh, so basically, yeah, it'll be about getting started, and then we'll go into some of the features and functionality of Pixi. And then after that, what we'll do is we'll look at what's new in version 4. And finally, depending on how much time we've got left, I'll go through some real-world examples where people have actually used it to make real-life things. Okay. So first things first, an overview of Pixi.js. What is it? Pixi.js is basically a 2D rendering engine built in JavaScript. So its sole purpose is to put stuff on the screen for you and make sure that it looks correct. The main drive that we have for it is that we really wanted it to be fast and performant. So it kind of just tries to take care of all of that for you without being too complicated. Under the hood, it uses WebGL, which is the fastest and best way to render stuff onto the screen because you get to use the GPU. A lot of people, I guess, will know WebGL. A lot of people also think that or believe that it's mainly used for just sort of 3D and really amazing 3D content, but it can also and is really great for rendering 2D content also. And Pixi's sort of party trick, which is kind of less relevant now in a world where pretty much everything supports WebGL, is basically that it seamlessly falls back to Canvas. So back when we made the engine, there was a time where most mobile devices and even most browsers didn't really fully support WebGL, and we wanted to make all of our cool content and all of our games. And unfortunately, if we had said to our clients, hey, we're going to make it only in WebGL and only 30% of your users will be able to play the game, they'd be like, nope, and we'd have to find a different way. So we put the fallback in so that it meant that it would work for most people because Canvas was pretty much everywhere at the time. So it's got pretty good parity. Like they look pretty much exactly the same. WebGL has a few extra features that Canvas is just pretty much impossible to do in Canvas. So things like filters, and obviously WebGL is orders of magnitude faster as well. Okay, so Pixi is also hopefully easy to use. We take great care in kind of imagining from the top how we'd want to do something. So we'd be like, oh, how do we want a mask to work? Oh, we want to go this object.mask equals this mask. And then we kind of figure it out from there rather than, so from the outside in rather than from the inside out. So yeah, hopefully it's easy to use. And then the other one, which is a big one, is it's free, open source. And it always will be free and open source. I think the only reason it's kind of got to where it is now is through the help of the community and all the kind of clever people that have helped us along the way. Okay, so why is Pixi.js? Why did we make it? So back when we first started Good Boy, we were kind of a little bit worried because our history was in kind of Flash, and Flash is dead and no one likes it anymore, and it's like a toxic word that I get scared about saying, but it was a really great piece of a great tool to make content in. But as the rise of mobile browsers came up, there was no home for it, and also it's kind of a bit slow. But there was, great tools, and it made really exciting stuff. And we were kind of a little bit worried when we started our company that, oh, how are we going to make this stuff? Do people even still want it? So we kind of made Pixi to kind of allow us to kind of carry on that thinking of making those extra level kind of creative things like games and kind of just sort of website experiences. So that was kind of a big reason why it was created, so that we could carry on doing the stuff we used to do. We needed it because it's a time saver. Once we had our renderer working, it meant that we didn't have to make a new renderer each time, and hopefully that makes sense that it's very time efficient to do that. It was also a bit of a sneaky promotion for our company as well, because as we started it, we were basically just kind of two guys in our living room, and no one had ever heard of Good Boy. So we thought, well, if we make this piece of technology and it's useful for us, if we open source it, then it might increase people's awareness of us and what we do. And then the final reason why Pixi exists is because, being a big nerd that I am, I absolutely love making renderers. It's kind of like the perfect match of technical and creative coding, which is my favorite place to be. So throughout my career, I've always kind of had a little go at making a renderer in whatever technology I've been using, 3D and 2D. And weirdly, there was actually, at the time, there was just a big hole in JavaScript for 2D renderers, which is kind of, again, like the need and why we made it. So yeah, I genuinely enjoy making this stuff. It's not work for me. Okay, cool. So why should you use Pixi.js? So there's certainly some good reasons and some bad reasons to why you might want to use Pixi.js and why you should probably avoid it. So we'll go through the good uses first. So if you need next level 2D visuals, so sometimes CSS isn't going to cut it. If you need to do some really complex transforms, or you need a lot of stuff on the screen, or you just need that kind of, you want to use some really cool effects, it's kind of just gives you more power. Pixi can really help out there, and it's very performant. It's really good for games. So it's not a game engine per se, it's kind of a component of a game engine. So you can use Pixi in your game engine to render your game, because a game engine actually has loads more. So a game engine will have things like a physics engine and a sound engine, and it will kind of put it all together in a nice big thing. And Pixi is basically just the drawing bit. And that makes it useful for also things like experiences, which aren't games, but have a kind of a high demand for visual fidelity. So yeah, Pixi's great for kind of those like in-your-face experiences. As part of a traditional website, it can be used to enhance certain things. So if you get the chance to check out Pixijs.com, our website, it's kind of the perfect example. It's basically the website is all built in CSS and traditional HTML, but the header at the top is just a really nice visual bit that's kind of Pixi powered. And I think it can be used in those situations. It's kind of a smarter use of it. So there's that. Pixi can also be used to make apps. So we've kind of recently found that, I mean, it's not really just Pixi. I suppose it's all HTML technology, but it's sort of come to this point now where with things like Cordova, it's actually really great for packaging into apps, into games, and that kind of stuff. And Pixi, again, is just a useful tool for making sure you get decent performance out of the devices if you do package it up. So bad uses for Pixi.js. So when to not use it, basically whenever the primary MO of your website is to kind of convey information, and SEO is important to you, then Pixi is a bad choice to build your website, because it is essentially just a canvas, which is essentially just an image and JavaScript. So Google's little spiders will have a tough time finding out what's actually going on there. So not a problem for games and experiences, but a massive problem for a shopping cart website or something where you want people, you want Google to index and search stuff. And there are ways around that, but they're kind of, generally speaking, if your client wants a site where people can sort of have really good SEO, then you don't want to be building it with those technologies. There's one more on there which I haven't put, but I hope is obvious, is you don't want to use Pixi for stuff like 3D because it's only 2D. Cool. So next thing we're going to do is, I'm not too sure what level you guys are with Pixi, whether you've used it or whether you're brand new to the whole concept of it. But I figured what we could do is have a look at an example like this one, an amazing example of a little bunny, and I can kind of show you what is actually happening and how it's kind of doing it. So if we see here, there's a little bunny spinning at the top, and then if we go down to the code, hopefully you guys can see it okay. Basically, I'll just kind of walk through the lines and explain what's actually is going on. So the first line is basically, this is how you create a Pixi renderer. So basically you just go Pixi dot auto detect renderer, and then you give it a width and a height and various different options such as background color. Auto detect renderer will basically do a little check on your computer, and it will go, hey, this guy's got WebGL, give him the WebGL renderer, or oh, this is an old browser and it only supports Canvas, and it will give you back a Canvas renderer. Now the cool thing is, it shouldn't matter which one you get back, because the APIs are exactly the same, and the features are almost exactly the same, bar a few tiny things like filters I mentioned before. So that's kind of really nice. It just means you don't have to worry about it. It means it kind of will work everywhere. Cool. So then the next thing you need to do there is just line 2 is basically append child the view, which is basically the renderer's view is basically the canvas element. So you stick that in your DOM, and then you end up being able to see it. Cool. And then the next thing you do here is you create, we've created basically a Pixi container. So, and we've called it stage. So this will basically be the container that all stuff in here will get rendered. Pixi basically uses a scene graph, which again is pretty similar to a lot of rendering engines. A scene graph is just a really amazing way to organize the way that you render stuff. So basically, if you add things into a container and then you move the container, everything inside that container will move with it. Again, anyone who's familiar with Flash will kind of hopefully get that concept. So the next thing we do is we create a Pixi texture. So it's got a few handy little functions that make life easy, and one of them is from image. So to get a texture from a URL, you just go from image, and then you pass in the asset, in our case, littlebunny.png. And then we go ahead and we create our bunny. So we're using a sprite here, and basically a sprite is kind of like what you add to the stage, and a sprite needs a texture to sort of represent it. And so we give it the bunny texture. So basically now we have a bunny sprite with a bunny texture, and when we add it to the scene, obviously you can see him, he's spinning around. We set the sprite's anchor point. This is a slightly trickier thing to kind of explain, but an anchor point is kind of like, how is the texture aligned to the sprite? So if you align it 0, 0, then it's kind of the top left corner of the image will be the center of the sprite. Whereas if you align it 1, 1, then it would be the bottom right, and 0.5, 0.5 means it's kind of smack bang in the middle, which is why when the bunny rotates, he rotates from his center. Next thing we do is we move the bunny by saying it's position.x and it's position.y. So in this instance, he's not actually, I realize he's not actually in the middle, which is where he's meant to be. So if I refresh this, then you can see he's now in the middle. This is how you add stuff. So we take the bunny and we've added into the stage. So now we've got a stage with a little bunny inside. And then we start animating. So to do that, we call the animate function, which has a request animation frame inside it, which means that the animate function will get called basically 60 frames a second. And then each frame, we basically update the the bunny's rotation. And then we basically call the magic function renderer.render, and we pass in the object that we want to be rendered. And in this case, it's our stage with our little bunny in. And that's that. So that's how you make a bunny that spins on screen. I know it's not that impressive, but hopefully it shows you guys the fundamentals of it. Okay, cool. So yeah, if you have any questions, obviously, feel free to post them in the comments, and we'll get to them once we've finished the talk. Okay, right. So next part is basically the features of Pixi.js. So all the stuff it can do. So I figured the first thing I'll talk about is and sort of explain how a little bit, just because hopefully you guys might find it a bit interesting. Is basically, yeah, the main feature of Pixi is that it's fast and designed to be to put as much stuff on the screen as possible, and giving you guys more power to kind of focus on doing all the other stuff. And we kind of will try to make intelligent choices behind the scenes to render stuff as efficiently as possible, but without demanding too much knowledge from the people using it. And batching is a really good example of how we kind of do that. So super top level WebGL, to render an image in WebGL, you essentially have to render it as 2 triangles, which is often called a quad. The little guy here shows just that. Okay, cool. So this is basically the slow way of rendering stuff to the screen. So if you imagine that each one of these little sections is an image, but they're the same image. So they're from, say, like a sprite sheet. The slowest way of doing it is for every image you draw on the screen, you do a GPU call. So you kind of go, draw this piece of petal on the screen, draw this piece on the screen, draw that piece on the screen. And basically for every object on the screen, you have a draw call. This is easy to understand. For 5 things, this is totally the way to go. But it can get slow if you have tens, hundreds, thousands of objects on your screen. So the fast way in traditional renderers is that they'd have something called a batching container. So you'd kind of create a instance of it. You'd go new sprite batch, and then you'd kind of go, this is the texture that I want all sprites inside here to use. And then you'd add them in, and it would basically know that everything inside that container would be the same texture. So because of that, you can actually batch all of that into one draw call, which is super efficient. So this is kind of like the way you want to go. Now, the Pixi way is kind of like, well, we didn't really want people to have to worry about sprite batching and what a sprite batch is and how it works. We kind of wanted people to kind of just add stuff to the stage, and behind the scenes, we would kind of make it happen if we could. So the example here on the left is kind of how Pixi, when you render it, kind of crawls through the scene graph, and it will do a check to see if something is the same texture. And if it is the same texture, it will automatically batch it for you. And here you can see, even though the scene graph is just kind of, as the user created it, because they're all the same image, Pixi will automatically batch them together and draw it in one draw call. Now, in the case of if you've got, as it's kind of crawling through the scene graph, if you've got different images in there, what it will do is it will kind of automatically sort of not, it won't batch them basically. So you can see here, it draws the first thing, then it sees a little bee, then it does a different call for that, then it sort of sees a part of the flower again, and it will draw the next 2 because they're the same texture, and then it'll do another call for the bee. I'm hoping this makes sense. It's quite a tricky thing to explain, or maybe, but yeah, I'm hoping this makes sense. So you can see here, as you remove a bee, Pixi would automatically turn this stuff, turn those last 4 back into a batch. And if you remove the other bee, oh, gone too far. But when you remove all the bees, you basically end up with this stuff batching again. Oh, I'm getting a bit lost now. Cool. So I don't know if I've done a good job of explaining all that, but basically Pixi does all of this for you. So you don't really have to know about it. It kind of all just happens behind the scenes. And now this is a little thing about v4. So up until version 3, like Pixi could only batch things that had the same texture. So when I say texture, I basically just mean image. So just traditional HTML style image. So if you had 4 images, then Pixi would basically have to do 4 draw calls. But in the most recent version of Pixi version 4, we kind of come up with a much cooler, smarter way of basically allowing Pixi to batch even textures that are different. So depending on how good your computer is or how good your GPU is, most devices can batch up to 15 textures. Mobiles, it's usually a little bit less, but it means that it basically means that Pixi has even less draw calls in the latest version, which, like I say, you guys don't need to worry about too much, but what it means is that things are faster, and that's only a good thing. Cool. So I figured a little performance comparison might be a good thing to show you guys. I don't know how smooth it is as you guys are watching this on a webinar, but basically, I'm just checking something here. Oh, cool. Yeah, cool. Sorry, just checking something there. Cool. So basically, we'll go through and I'll show you guys the three rendering examples, and you guys can kind of see the performance difference. So we'll start off with a DOM renderer. So here's a little thing we call the bunny mark. So cool, it's actually running a little bit slower here, I guess because I'm doing a live feed through my computer. But you can see here, as I add little bunnies, you can see the frame rate starts to dip. If I'm just going to get this to 1,000. And there we go. Okay, cool. So you can see here in the DOM, basically, so each one of these bunnies is actually like actually a HTML image, and it's just being transformed using CSS, and that's how they're kind of getting bounced around. So you can see there that you're getting about 1,000 bunnies at 32 frames a second, which is cool. You know, you don't often need 1,000 things on screen, but it's kind of so again, like CSS is totally good for some of these things. So then we can kind of look at Canvas. So this is the Canvas renderer. So if I get this up to 1,000 again, you can see here that at 1,000, it's actually the frame rate is better. It's close to about 40. Usually this is about 60, but I think because I'm doing a live cast, it's getting a bit slower. But if I go up and I keep adding them, you can see that the frame rate's fairly stable. I'll just keep going until it drops to under 20. So yeah, if I go to about 5,000. Anyway, so you can see here though, basically using Canvas to render stuff is much faster than the DOM. You can see here we've got basically 5 times as many, and it's running about the same speed, maybe even a little bit faster, which is really cool. So that's basically just using Canvas and going draw image and using the Canvas API to place stuff. So you can see that's pretty good amount of bunnies, more than you'd need for most games, I imagine. And then this is the WebGL renderer. So again, usually this is 60, but if I add the bunnies here, you can see here I've already got, there we go. So there we've got 5,000 bunnies, and that's running at an all right frame rate. I mean, you could try these out after and go to the links, and they should run a bit better because I'm not screencasting. But the cool thing with WebGL is that if I hold this down, you can see that you've gone from 1,000 in DOM to 5,000 in Canvas, and then in WebGL we've gone to 50,000, and it basically just kind of keeps going, which hopefully will show you how fast WebGL is when you kind of know when you basically you can kind of optimize it behind the scenes. So I'm going to take this all the way to 10,000 to sort of show you guys that even at 10,000 it runs faster than DOM and WebGL. So like I say, you're never ever going to need sorry, that's not 10,000, that's 100,000. So yeah, hopefully that shows you guys that yeah, you know, it's WebGL is fast, and hopefully Pixi is fast also. Right, so let's just close this. Okay, cool. So let's go on to the next slide. Okay, cool. So this is basically the rest of the stuff that Pixi has. So I kind of touched on some of it already, but I'll just kind of go over some of the other features. So basically, the first one here is the scene graph, which I mentioned before. So basically the ability to create containers and nest things into each other for really kind of easy manipulation of things. It has sprites, which is what the bunnies were, so just images on screen doing stuff. It has support for text, including formats as well, so bitmap text, regular text, and different styles and different fills and kind of things like that. It has a graphics API, so you can render kind of vector graphics. It comes with a bunch of loaders that let you load in all of your assets. It has render textures, which are basically sort of the ability to draw stuff to another surface and then use that surface as a source in a sprite to basically, it's kind of a really, trying to think of a good use case for it. It's basically a really powerful tool. I think I'll show you guys some demos in a second. Hopefully it'll make a bit more sense. It also has a thing called cache as bitmap. So that's if you're rendering 1,000 things on screen and none of them are moving, then you could set cache as bitmap to be true, and what it would do is kind of draw an image of that, and then just going forward, not draw the 1,000 things, but just draw that one image. Pixi also has filters, masking, ropes and meshes, blend modes, interaction, and accessibility. So what I'll do is I'll kind of show you guys the filters. So this is our filters example that we made. This is getting a little bit old now, but this is for V3, I think, but everything still kind of applies. So This is basically some fish sprites and a background sprite moving around with a tiling sprite water effect. And then basically what we've got there is a displacement effect, which is essentially, if I kind of scale this up, you can kind of see it kind of, it's basically like a nice effect that kind of distorts stuff. Pixi has a bunch of filters that are already pre-made. So if I go through some of these, you can see here, this is like a blur filter. So you can kind of blur stuff. It's got really fun stuff like pixelate, so you can make it look like an 8-bit old school game, and you can modify all this stuff too. What's really interesting is you can actually chain and have multiple filters all working together. So for example, if I go to this twist filter, which is super fun, you can see it's kind of like, all right, cool, twisting stuff around, but then I can also apply the pixelate filter, and you can see there that you'll kind of just sort of stack the filters on top of each other. And now this is really cool because it just means that you can kind of come up with some pretty crazy effects. So let's just get rid of some of that. I can show you some of these kind of slightly more mental ones, like this dot screen one. It's pretty cool, makes things look like an old newspaper, which is pretty fun. And then you've got really bizarre ones like this crosshatch. I don't know why you'd ever need to use this in real life, but it's kind of a cool thing to show how powerful WebGL is when it comes to filters. And then you've got like an RGB split, which basically just splits the RGB channels of an image. And again, you can go to town and really just slap all these filters on and make a nice digital mess. Cool, so they're the filters. So I think what I might be able to do is actually just quickly show you guys, I'll go through the Pixi.js examples and actually look at, show you some of these things in practice, like just quickly sort of glancing over them. So what have we got here? So this one is not quite one of those less glamorous things, but Pixi has a full interactive, is fully interactive, so it responds to all mouse events and touch events. Even though this is basically just a canvas, we kind of make it feel like these things are more. So Pixi has full interactivity. You can literally just go myObject.interactive equals true, and then you can attach mouse events and touch events to it, and it will just kind of listen to that stuff for you. Here's another really basic example of dragging stuff around. And again, on touch, you can kind of do that kind of stuff. Here was the text that we talked about, multi-line text, bitmap fonts, spinning text, always handy. So next I'll show you guys render textures. So this is a crazy use of it. So this is basically rendering a scene and then drawing it to a texture, and then using that texture as the thing you render and basically flip-flopping between the two. And what you get is this really trippy but quite cool effect. So all we're really drawing is those little objects in the middle, but the way that the textures render make it look much more interesting. The next thing is graphics. And lines and cool stuff like that. So basically this is kind of like the vector stuff you can do. The API is really simple. So here's drawing a shape. You create a graphics instance, and then you kind of go begin fill, align style, and then you can move to line 2 and end of fill. So again, really handy for the odd graphics things. Graphics aren't as fast and optimized as sprites, but they are still pretty nippy. Masking. So we've got the ability to mask content. So if I click here, you can see there's basically a background there of that kind of crazy 80s style thing. And if I click here, you can see that this becomes the mask. Again, not really that glamorous, but my gosh, it's like without masks, you'd be lost making stuff. Cool. So then the blend modes, which you touched on. So that's the ability to just change the way that the images are drawn to the screen, like how they're drawn to the screen. So this is basically an add blend mode, I believe. So you can see they basically, as they kind of overlap, it kind of looks really cool. I've actually got like a little demo of blend modes here, which are these little lasers. But yeah, blend modes are kind of a designer's friend. They'll always want you to do some kind of crazy blend modes on stuff. And with Pixi, you can indulge them. Yeah, so you can see here basically when these lasers start going a bit more nuts, that you start to get this really nice sort of burn effect, and all that is just literally because of the blend mode, which is kind of cool. Ropes and meshes. So we've got this this little snake guy is a good example of that. So the cool thing about WebGL, so with Canvas you can stamp images and that's no problem. But this is the kind of stuff you can't do in Canvas. But I mean you can, but it's really slow. This is the kind of stuff that WebGL is kind of born to do. So this is kind of making use of the fact that you can have more than just two triangles to draw a shape. So this little guy is basically, he's a bunch of points and a bunch of triangles, and we're kind of animating them to sort of distort the image and make it feel much more interesting than just kind of an image of a snake. This is actually using something called a Pixi rope, and I believe there is actually a demo of it here. So you can actually see it, and you can actually see the code for it here. This just in the middle here, this is how we kind of move them about. But yeah, the code is all there for you guys to kind of have a little play with and enjoy. Yeah, okay, cool. So I think that kind of covers a lot of the functionality. If you guys have any more questions on that stuff, again, just write a comment and we'll get to it at the end. So that's the majority of them. Okay, cool. So the features of Pixi.js version 4. So we literally about a week ago, or maybe 2 weeks ago, released Pixi.js version 4, which is the latest and greatest version. There's a lot of updates. I hesitate to call them features because there's a lot of kind of behind the scenes stuff that we did that just kind of hopefully makes things a bit faster and a bit easier to grow in the future. So the first thing is we refactored a lot of the WebGL stuff and put in a lot of optimizations. A lot of the WebGL stuff comes from, we created a new low-level WebGL API called Pixijs Core, which is basically a kind of layer on top of WebGL to make working with it easier. And then Pixi is built on top of Pixijs Core to give the user an even more friendly API. But the idea is that, and this is kind of Pixijs Core is finished, but it's not documented, which is what, so it's not that accessible to people just yet. But the idea is that for people who are super WebGL savvy, you can kind of just pop the hood there and just kind of create crazy WebGL stuff. And then when you need to do the stuff that you just need to do, like create a button or a menu item, you can kind of just go back to rendering regular Pixi. So the idea is that people with more WebGL skill and who are more familiar with it can kind of access that stuff. Okay, so the other thing that we did with Pixi.js was that version 4 is much faster on iOS. So we found that when Apple released WebGL on Safari, initially it just ran amazing and it was really cool. And then a couple of minor versions into version 8 of iOS, they kind of introduced this really weird quirk, which I probably won't go into because you'll probably all fall asleep. But basically what it meant was that this quirk meant that occasionally if things weren't set up the right way, then it would run a lot slower than stuff in Pixi would run a lot slower than it should have done. But we figured out what that quirk was. It was re-uploading the same buffer in the same loop. Basically, that was kind of iOS just seemed to decide one day that that was bad. Not a feature of any other browsers, but either way, it doesn't really matter too much because we figured out a way around it, and now we got that performance back, which is great. So that's why version 4 is good for, especially good for iOS. The other thing which I mentioned before is we now have multi-texture batching. So that means that more textures can get batched together, which basically just translates to more performance. The other thing we introduced is the concept of static transforms. So again, reading that actually sounds quite dry, but it is quite cool. So the idea is that we were kind of seeing that when we were making stuff and other people were making stuff in Pixi, it feels like everything's moving around and there's loads of activity on screen, but in reality, most things don't move around and don't change that often. So previous versions of Pixi kind of lived on an assumption that everything you do is moving all the time, which just isn't true. So what we did is we created a static transform, which basically it's only when you change it that it kind of flags itself as dirty, and then in the update loop, it will actually recalculate its matrices and then its children's matrices. So basically what happens is if the things that aren't moving basically don't get updated, which is kind of a really nice little performance boost. And it's much more handy in real world situations of actually when you actually make stuff, rather than just say like a demo. The other thing that we introduced to Pixi version 4 is the garbage collection. So again, like going back to the whole point of like, we really want Pixi to kind of just be advanced, but we want the API and the users to not have to know about it, keep it nice and simple. There's a couple of elements that happen in Pixi and in WebGL that you just can't really manage, the JavaScript won't manage. So for example, every time you upload a texture to the GPU, you have to delete it yourself, using JavaScript. You can't, it won't, there's nothing to automatically look at a texture in the GPU and go, hey, that's been sitting there a long time. We should probably get rid of that before it fills up. And that's what the texture garbage collection is. So what we do is, as you render a scene, textures get tagged as being in use. And every now and again, and there's no performance hit here, it's minimal, because basically every 10 seconds we slowly, over time, crawl over the scene graph and kind of go, oh, look, this texture hasn't been used for a while. And if it hasn't been used for quite a while, what will happen is it will just kind of remove it from the GPU for you. And then next time it needs that texture again, it will kind of just upload it for you again, and you'll have never known. So it means that it's just one less thing to worry about in terms of like filling up the GPU, and kind of Pixi will just kind of take care of it for you, or that's the goal anyway. So yeah, not such a big problem on our meaty desktops, but can be a real pitfall on mobile devices. So a good example would be, say you create a game, and then you've got your amazing loader and then your amazing title screen with all your cool animations, and then the user goes and plays the game. You can remember and go, make sure to unload, you can write specific code to unload the textures from the GPU. You can destroy things in Pixi, but most of the time people don't remember to do that, or shouldn't have to remember to do that. So what will happen is, with texture garbage collection on, you'll kind of go to your title screen, you'll see all your cool animations, then you'll go to the game, and then over time, Pixi will realize that the images and textures that were in the title screen haven't been used for ages, and they'll kind of go, hang on, this hasn't been used for a while, so I'm just going to remove it from the GPU, and it will do that, and then you won't know. It just means that the amount of GPU memory just gets freed up a little bit. And then the next time you go back to the title screen, it will kind of go, okay, cool, just pop that texture back on there for you. Yeah, so it's really cool. Again, just kind of trying to take a complex thing and make it simple. Okay, cool. So the next thing that's cool with version 4 is that we have tried to make it so that you can mix it with other technologies. So the example here is basically mixing Pixi with Pixijs. So this isn't like mixing it like, here's two canvases. This is mixing it so they share the same WebGL context. And like the comment says, there's a plugin coming soon. So Samba time. Okay, cool. So this is a game we recently released for Cartoon Network during the World Cup. So you can see here, basically, all this stuff is basically Pixi, nice UI for Pixi, which is what it's good for. It's what it's kind of fast for. These two bears. And then you go into the game, and it kind of, this bit is basically, I'm going to be able to control this. So I'm going to be a pro. I'm going to try and score a goal. Yeah, cool. Okay, so basically you can see here that basically this whole game is powered by Pixijs, but all of the UI is powered by Pixi. And you can see that they kind of seamlessly mix together, and hopefully, you can't even really tell that they're two different things, because we found that like now more clients want WebGL. We can do some kind of cool 3D stuff, but we still need that kind of speed for the 2D stuff. So I guess that's a kind of a cool new use for Pixi, is like it can be your UI friend when they're, all the kind of crazy 3D engines can be your 3D friend. Cool. Okay. So we've got, how long have we got left now? We've got about 5 minutes left. So I could quickly basically go through some Pixi.js in the wild. What I kind of want to show you first is probably, because we've only got 5 minutes, I'll probably show you guys just some of the cool experiments that we did in Pixi, but I'll share this slide so that you guys will be able to see all this stuff. And also all of these projects that I don't show will be in the gallery of Pixi anyways. So I wanted to show you guys this because I think it really showcases the stuff you can do in 2D that isn't just, oh, I'm a 2D image. So what we've got here is basically 2D, I guess you'd call it geometry-based lighting. So what we've got is kind of the shadow casting effect of this light. So that's kind of done using, I think it's done using Pixi graphics, and then that's being masked by a gradient. And then the other thing that we've done here, which is a really cool 2D effect that makes things look 3D, is these presents. They kind of look 3D, but they are 2D, and what they have is things called normal maps, which basically sort of informs the sort of present how to sort of light itself based on the position of this light source. So it means you can see as I go around the present, the kind of light kind of changes. It's kind of cool. And then the other cool feature in here that is a bit subtle is if you follow my mouse into the corner, you can see there's kind of like the edges get a bit scratchy, a bit frosty. Now the thing we've done here is basically use the displacement map to just kind of offset all the pixels. Yeah, and you can see when you put it all together, like it means that, like, you know, 2D is, you can do a lot of really cool stuff in 2D, and I think this example shows that. Okay, cool. So the other one which we have, which is pretty cool, is the this sort of Christmas cracker. Again, kind of more of a demo than a thing, and it's fairly old, but I kind of like to show it just because I think it kind of captures quite a few of the cool things that you can do in 2D. This is basically a Christmas cracker that uses the rope. The same thing as the little snake example did. So you kind of basically got this little cracker that you can kind of give a little pull to, and we kind of added some little physics to the ribbons. And also the shadow of the cracker is basically the kind of the dot matrix filter that I showed you guys before. The background is basically just Pixi graphics. And then if I pull this little guy, yeah, there you go. You can see, like, basically that kind of has a displacement map and loads of these little Christmas cracker particles, which are kind of quite fun and handy. Cool. Again, just kind of like 2D, but like kind of more interesting than just putting stuff on the screen 2D. Okay, I think I'll show you guys this one. So this site is called Jetlag, and I like showing people this one because I think it's a really good example of a website that is kind of cool to look at and has really good motion, but you kind of wouldn't really maybe think of it as being used in something like Pixi. So this is really cool. You kind of click and drag, and then you can kind of flick up the scene, and it will kind of just do this really nice thing where it kind of will break it all up, break up the image. And again, like, I'm not sure how smooth this is appearing to all you guys, but if you go to this site, not with a screencast, it will run at 60 frames a second and feel really slick. And you can kind of click on these, and it kind of just has this really nice kind of way of dealing with stuff. Yeah, again, I think this is a good example of a Pixi website because it's kind of something that you could probably do in HTML and CSS, but like something like this kind of effect here would be very expensive and probably not run quite so fast. So yeah, there's that. So I think probably, yes, got to the end there. So yeah, basically that's that. Hopefully that was helpful to you guys, so you can get your head around what Pixi.js is. If you want to know more, you could go to pixijs.com, which is the official website. If you want the latest up-to-date information, you can follow me on Twitter. My Twitter name is doormat23. Any kind of big stuff that we have kind of goes through there usually. And then we also have a blog, which is goodboydigital.com/blog. Very creative name. Yeah, so I think, yeah, that's a wrap. If anyone has any questions.
So
Good to
now
answer
it's
them.
the Q&A session. So we have 4 questions in the comment section. So the first one is, how do you create big,
Hello.
draggable, touchable background worlds? Can you see the question, Matt?
Can you guys hear me okay?
Yeah.
Do you know what? I just hit my mute button, so I just missed whatever you might have just said.
Okay. All right. So the first question is, how do you create big, draggable, touchable background worlds?
Ooh, that's many questions. How would I do that? I mean, there's a few different ways, really. I guess. So it depends how big, right? If you've got like a world that's massive, like we're talking like ridiculously massive, then you probably need to sort of start taking into account things like culling. Pixi doesn't really deal with any of that because we tried to add it in, but we found that it kind of is more of an app level thing. So all this kind of stuff where like, yeah, you want to make a massive world is kind of something that you'd kind of need to build on top of Pixi with. So you'd kind of, you could use the touch events and you could kind of go, oh, here's a mouse down, and you move stuff about, and you could obviously use the events to kind of move the world around. But yeah, the question's pretty big. I'm trying to think of the best way to answer it. Yes.
All right. All right.
That was very helpful
Let's
too,
move to
wasn't
the next question. So the second question is, how textures and sprites differ exactly?
Yeah, okay, so a sprite is basically something that goes into the scene graph, and that's a thing that gets drawn and rendered, and it has a position, a scale, a rotation, a skew, so it has a transform. A texture is basically the image itself. So say, for example, the image of the bunny, if you were to look at that, that would be like just a regular PNG. So a texture basically uses an image source, and it's kind of just the image on its own, and the image has no concept of where to go, how to scale, or how to position itself. That's something that the sprite kind of deals with, and you basically the sprite is basically like a container that kind of shows an image or a texture, and that's kind of how that works.
All right. And the third question is, this is really long. So is there a way in the API to read all the pixels of a container or even the whole stage in order to do image processing, such as edge detection or basic computer vision?
Yeah, there is in version 4 of Pixi, there's kind of it's called extract. So all the renderers have a renderer.extract, and then you give it an object. You give it the thing that you want to extract, and what it will do is it will return either an image, a canvas, an array of pixels, or basically anything you need. But I think really the question is, you kind of wouldn't want to extract the pixels to sort of do edge detection and that kind of stuff, I guess. I think that would be something that would be better placed by writing a shader or a filter to kind of run through an image and actually kind of do all that stuff on the GPU. But you could pull it out with the extract function.
All right, and on to the very last question. Why is the texture GC disabled by default?
Oh, because I was a bit scared to basically make it enabled by default. But I wanted to we wanted to create a few more real life projects with it active to sort of be able to come back and go, yeah, okay, this works really well. But the good news is I think it does work really well, and we're using it in quite a few projects now, and it's kind of really nice to just see the GPU, memory GPU just kind of go down over time and kind of manage itself. So I think in future, and maybe in the next release, it will probably be set to true.
All right, and we actually have another question.
Cool.
If you don't mind.
No, I don't mind.
So can you share any examples of using Pixi to draw graphics? like lines, circles, etc., rather than compositing bitmap textures?
Yeah, I mean, if I, hang on, let me just go back to my screen share. And you guys can see my screen, right?
Yeah.
Cool. Okay, so what is a good example? I mean, I'm trying to think of what would be a good. I mean, this is not really nice to look at. I admit, but it is graphics. Pixie's. I mean, I wouldn't use Pixi to create really. If your main thing is like vectors and precision and kind of like SVG style stuff, then I think SVG is a better world for that kind of stuff. But I mean, I will have to try and find some good examples of graphics in use. They tend to be used as kind of to complement a bunch of stuff. So I mean, if I go back to I mean, let's see if this has got like any. I mean, graphics can basically be used for. I mean, images are basically faster. So this is Androidify. This is kind of built in Pixi, but I'm just trying to see if like if these are maybe used using shapes. They're probably not. They're probably just all images actually. I will have to look. Basically, most of the time, I think people use Pixi. And they use kind of everything in like together, if that makes sense, rather than. But you could technically just make a vectory looking game. It's just not something I've seen much of. I would have to go looking for an example, basically.
All right, I think that's all the questions that we can cover for now. If there's any other questions that is not covered, I will send it to Matt, and I will respond back to all of your questions right away on the YouTube link. And so thank you, Matt, for presenting, and everyone for watching another Be My App webinar. Just so you know, this webinar is recorded, so feel free to share the YouTube link or rewatch them. Also, if there's any slides, again, I will post them on the comment section. So thank you again, everyone, for watching, and until next time.